Welcome. In this video, we're going to be discussing quartiles and interquartile range. In statistics, we want to understand why do we use quartiles or interquartile range. Let's take an example. If we had a data set of values, let's say these are Ali's marks in mathematics, and they are distributed in a way that you have 71, 73, 68, 38, 75, and 69. The range in this case would be his highest, which is a 75, minus his lowest, which is a 38, and the range would be a 37. Now, in this case, the range is greatly affected by one mark which is very low compared to the rest. Let's say on that day maybe Ali wasn't feeling fine, so he has a 38. The range wouldn't be the best measure of spread in this case because it's being affected by this data value is called an outlier. These are values that are either very small or very big compared to the other data sets, because his marks are in 70s and lowest 60s, and then there's another very low mark which is 38. It is affecting the range. If we ignored the outlier and we calculated his range without the outlier, it would be a 75 minus 68, which is a 7, really quite low. Let me compare it with another data set. Let's take, for example, Betty's marks. Betty's marks, her marks are 42, 60, 72, 77, 54, and 79. These are from the same math tests as Ali's. So let's say these are Betty's marks for maths. In this case, if we calculated the range for Betty's marks, it would be 79, her highest, minus 42, her lowest, which is also a 37, similar to that of Ali. But then their marks are not distributed the same way. You find that Betty is kind of evenly distributed because she has 70s, 60s, and 40s, whereas Ali has 70s and 60s only, but they have the same range. Now, because of range being affected in such a way, it does not give us a good description of the marks of both Betty and Ali. So we introduce in another measure of spread, which is called the interquartile range. Now, the interquartile range is meant to solve the issue of outliers affecting range, and then range where you have the same range but different distributions. So what is interquartile range? We are going to start with talking about what we call quartiles, because interquartile range comes from quartiles. If we have a data set, let's say this is our data set. You have values, let me start from 37, you have a 39 somewhere, you have a 40, you have a 41, you have a 43, and let's say you have a 52 somewhere. Quartiles is when you divide this data set into 4 equal parts. Okay? The first one, which I would call the middle quartile, I'm going to abbreviate it as Q2, is actually the median. Okay? That's the middle quartile. You divide your data into 2 equal halves. Then the lower quartile divides this first half, which has the first part of the median, into 2 parts. I would call this Q1. And then the other quartile divides the upper part of the median into two parts, and I'll call that Q3. Hence, having your data divided into 4 equal parts. From the definition of median, it's basically dividing the data into exactly a half. So your Q2 would be a half of your total data, where n is your total data. Let's say if you had 9, or if you had 10 data sets, if you had 10 parts of your data, like 10 numbers, the median would be in the 5th position. That is n divided by 2. Then my lower quartile would be a quarter of your total data, and my upper quartile would be 3/4 of your total data. That is n. So interquartile range becomes the difference between the upper quartile minus the lower quartile. That gives us the interquartile range. Now, why do we use the interquartile range once again? In order to cater for the fact that range may not give us a good measure or analysis of the data, range in its own. So we divide the data into 4 equal parts, which we call quartiles. That is Q1, Q2, and Q3, where Q1 is a quarter of your data, Q2 is a half of your data, which is actually the median, and Q3 is 3/4 of your data. In the next video, I'll be explaining how to calculate the different quartiles and the interquartile range.